Good day everyone, this is Ira Lacanaria and welcome to another video. This video is all about related rates involving diamond baseball problem. So let us start. A baseball player running from second base to third base at a speed of 20 feet per second. He is currently 70 feet away from the second base. The baseball diamond field has the shape of a square with a side length of 120 feet. Now the question is, at what rate is the distance between the player and the home plate decreasing? So to fully understand this problem, let us have our illustration here. So we have our diamond baseball field here, and let us label this part as home, this part as first base, second base, and third base. Now, a baseball player running from the second base, so from this to the third base. So we have our baseball player here running at the speed of 20 feet per second, and he is now currently at the 70 feet away from the second base. Now, the baseball diamond field has the shape of a square, meaning that all of the sides of the field has the same length, which is 120 feet. And we are asked what rate is the distance between the player and the home plate decreasing. So we can notice that we have here our right triangle at this part. So we will use this to solve what is being asked in the problem. So let us draw our right triangle here, and let us label the side with x, y, and z. So we are asked to find dz over dt. So to find this, let us first list the given that we can get from our problem. Okay, so to find the value of x, we can use the given here. So we know that the side length is 120 feet and the baseball player traveled 70 feet away from the second base. So we can get this part, the value of this part, as x is equal to 120 minus 70. So x is equal to 50. Now that we have the value of x, now let us find the value of y. So y is equal to this side, which is 120 feet. So for our z, we can use the formula of Pythagorean theorem. So we have here z squared is equal to x squared plus y squared. So our x is 50, so 50 squared, and our y is 120 squared. So 50 squared is equal to 2,500 and the 120 squared is equal to 14,400. So now let us find the sum of these two. We can get 16,900. So to find the value of the z, we will square root both sides. So we will have z is equal to 130. And we also have given here a rate of 20 feet per second at this side of our triangle. So it will be our dx over dt. The question is it decreasing or is it increasing? So we can say that it is decreasing as the player approaches the third base. Let us have our illustration here to fully understand if it is decreasing or increasing. So we have our right triangle here. This one is transformed to this one. So this part is our x. And here is our baseball player from this part traveling to the third base. So it is decreasing. Therefore, our dx over dt is equal to negative 20 feet per second. So now that we have these values, we can erase these figures or illustration to have our space. Okay. So now, let us find the derivative of this equation with respect to time. So the derivative of z squared with respect to time is equal to 2z multiplied by dz over dt, and our x squared is 2x dx dt, and for our y squared, since it is constant, we will have 0 here, the derivative of a constant is 0. So why it is constant? So let us draw again our right triangle here. Our x part is changing as the baseball player approaches the third base. In this case, our y is not changing, so our y is constant. So it is 0. The derivative of a constant is 0. In some cases, y is not a constant when it is stated that the player is from the third base to the home base. Okay, so now let us continue. Let us divide both sides by 2. And we will have z multiplied by dz over dt and x multiplied by dx over dt. Now let us use this equation and let us substitute this given. Okay, so for our z, we have 130, this one, and copy the dz over dt is equal to x, this one, 50. And for our dz over dt, we have our negative 20. So now let us multiply this. We have negative 1000. So copy, and we have our negative 1000 on this side. Let us divide both sides by 130. So this one we will cancel our 0. So we have our dz over dt is equal to negative 100 over 13, or negative 7.69 feet per second. So therefore, the distance between the player and the home plate is decreasing at the rate of about 7.69 feet per second. So we will not include the negative sign because it was stated that it is decreasing. So thank you for watching.